methane would be igniting in the flare, correct?
We don't need any more of these.
Hello everyone, and welcome to the countdown of a Falcon 9 launching 2 payloads at the same time going to the moon. My name is Adrian Bile. I'm here with you all to kick off this wild 24 hours of spaceflight that is ahead of us, and I'm looking forward to talk through everything moon in the next 55 minutes, because that certainly is the focus here for this first launch. But I'm not alone with this. I'm joined by a person that you always wish to have when you talk about Falcon 9. Alex, how is it going?
It's going fantastic, but as you mentioned, it's probably going to be quite a wild 24-hour, 25, depending on some windows out there, right? Some of those launch windows. Yeah, it's going to be wild.
Absolutely. It's it's a very special day in spaceflight with Blue Ghost, with Hakuto R, then with Starship, and with New Glenn, all in a matter of 25 or so hours. So yeah, you will get plenty of NSF coverage if you like our voices. Speaking of voices, I think in the field we have Sawyer making a comeback to the Cape here. Sawyer, how is it going?
It is going great. Yes, this is my Cape comeback finally. After 2 months of being knocked out with surgery, we are here. There is a Falcon 9 on the pad, and it's a little chilly, but it's a great day to go to space.
Let me also directly come to you, Sawyer. Do you want to give us a quick overview of what are these moon payloads that we are talking about here?
Sure. Yeah, we have 2 very cool payloads that are on their way. Of course, we have the Firefly Blue Ghost lander. This is the first Blue Ghost lander. There are 10 different scientific payloads on board. This is part of the NASA commercial lunar program that they have going with their commercial partners called CLPS. So there'll be 10 different instruments on board to measure all kinds of different things, from X-rays to a reflector to help measure the distance more accurately to the moon, as well as a way to try and ionize all of the lunar regolith, the dust, out of the way of the vehicle. So there's a lot of cool stuff on this particular one. Going along with it is the iSpace Hakuto R mission as well. That is the second one for Hakuto R here. So Japan will also have a lander on its way down to the surface of the moon. They are both hitching a ride together. The plan is for them to get into orbit. They'll take some time before heading out on their way to the lunar surface, with landings in the next month or so.
Absolutely, and this is, I mean, seeing 2 moonlanders at the same time is a wonderful and special occasion that we are getting to witness here. D, in the field, is it? Are you still blessed with cold in Florida, or is it a bit nicer than the days before?
You know, actually, yesterday was a bit nicer than the days before. So while we were getting ready for a potential New Glenn launch, it was really nice out. I was in just one sweatshirt, but since that weather has cleared, it has cooled back off. So it is a chilly evening here in Florida as we get ready for the launch.
Absolutely, and you will of course deliver tracking to us along the line here, so thank you for that. Also behind the scenes we have both Kevin Michael Reed and Jay Keegan standing by and bringing us all of the production magic. You can see all kinds of feeds there today being displayed. We also have Julia Bergeron in the field, and we have Max Evans in the field today. So really, we are, as Jack always says, there are no stops for this. There are no stops. They are all removed. And with that, Alex, do you mind giving us an overview of Falcon 9's payload? Not payload. Falcon 9's job today. What kind of landing do we have? What booster is this? Give us the rundown.
I'll go from the start, right? So in about 50 minutes and 48 seconds, we're going to have that liftoff. And so the rocket will head bit southeast, so it's not the southeast that we see, for example, for Starlink missions, but it's not going to be entirely east. It's sort of like, you know, an in-between kind of thing. It's going to head out southeast. The booster is going to fly for about 2.5 minutes. Stage separation will happen. This booster is Beaton 85, and it is flying for a 5th time, having supported 4 missions prior to this. 2 Starlink missions, Starlink Group 10-5 and Starlink Group 677, but also Crew 9 and GPS 3 SVO7, also known as RRT1. And so those 4 missions, hopefully this booster has read the instructions, because it's going to be landing on Just Read the Instructions out there in the Atlantic Ocean. That's going to be probably, if I'm not mistaken, the longest distance that any booster for Falcon 9 has flown to a landing spot on a drone ship. It's going to be 700 kilometers downrange, which I think it's a new record, because up until now, if I'm not mistaken, the record was about 690 kilometers. So this is about 10 kilometers further downrange. So that's going to be quite an interesting landing for the booster. Now, meanwhile, the second stage will ignite, right? And then it's going to enter a sort of like a parking orbit in low Earth orbit. And then it'll relight its engine again. That one should be a little bit later, essentially about 58 minutes into flight, or sort of like even close to 1 hour, right? After launch. That second stage relight will put both landers, the Firefly lander and the Hakuto R lander, in a high Earth orbit. So the payload stack for today, we have the Firefly lander on top, and that's going to be released right after that burn at about 1 hour and 5 minutes. And you know, that payload adapter that they have to be able to fit both landers together, they have the Firefly lander on top, and then they have this sort of capsule canister kind of thing that covers the bottom lander, which is the Hakuto R lander. So that canister will separate about 1 hour and 11 minutes into flight, and then we'll see another relight of the second stage, a very short burn, about 1 second long, about 1 hour and 26 minutes, to push the Hakuto R a little bit further beyond that high Earth orbit, to sort of go all the way to the Lagrange point 1 between the Earth and the Sun. We'll talk about that probably along the course of today's live stream. And then hopefully we're going to see that Hakuto R lander being separated 1 hour and 32 minutes after launch. As for the fate of the second stage, as you can imagine, it's going to stay out there in that, you know, sort of like heliocentric orbit out in space. So it's not going to come back. There's not going to be sort of a deorbit burn or anything, because it's going to go all the way out there. So none of that happening. Forgot, the fairing halves are also being recovered. You know, on that first burn of the second stage, the fairings will separate, and they're going to be coming back, and they're going to be recovered. And by the way, they are also reused, and one of them we think might actually be a record turnaround. We'll see if we actually can confirm that. And they're going to be recovered by the ferry recovery vessel Bob. So that's sort of the rundown of today's mission, sort of the timeline, what is being launched, and at what time they separate. But I don't know, if we have any questions, as usual, you know, tag in NASA Spaceflight in chat, and we can go over that.
Absolutely. Before we move to that, I want to quickly go to Sawyer here. Sawyer,
Hello.
Of course, these are two moon missions at the same time. So just to differentiate here, or just to point this out to the audience, these are not part of the same mission, right? These are like just they're kind of on the same bus here.
Exactly, yeah. At a briefing earlier today, they basically said that, hey, we had 2 missions that are going to the moon, and SpaceX said we could stick them both on the same rocket, and both parties agreed. So that is why we have the Blue Ghost one, which again, that is Firefly. So Firefly Aerospace has that one called Ghost Riders in the Sky. And then the other one is the Japanese company iSpace. That is the one that is Hakuto R Mission 2 Resilience.
There you go, and of course, Blue Ghost is part of the NASA Commercial Lunar Payload Services, CLPS, which is a name that we have heard in the past 1 or 2 years a bit when the moon came up. So once again, we have been blessed here by one of these CLPS landers, which already had such a rich journey in the past few launches. We had quite some adventures to the moon in the CLPS program so far. Let's see here. Alex is also wondering here, since you talked about performance, how light are those landers? Because it can't be easy for Falcon 9 to launch those both at the same time.
Well, ironically, we've already seen Falcon 9 launching a Hakuto R lander. The first one was launched on Falcon 9, and it's lightweight enough that it was able to do a return to launch site landing, right? But of course now it has also the Blue Ghost lander from Firefly as well, so it adds a bit more mass, and of course that means it is landing the booster on a drone ship instead, just to get a bit more oomph and more performance out of that first stage. So they need to land on a drone ship for tonight's mission. The combined mass, we think it's about, we don't know the exact mass of both landers, unfortunately, but we think it's sort of a bit under 3 metric tons, more or less, because the Firefly Blue Ghost, they claim it's about 450 kilograms of dry mass and about 1,000 kilograms of propellant on board for propulsion and everything. So that would mean it's about 1,400 kilograms, more or less. And the Hakuto R is also between 1,100 1,200 kilograms or so when fully fueled. So we think probably the combined mass of both landers, it's close to 3 metric tons.
There we go.
And one other
ahead.
thing that I should mention, though, because you may see out there maybe advertised things like, oh, they're carrying 155 kilograms. That's the payload mass on the lander. For example, Firefly is carrying a bunch of payloads. We may talk about those here in the broadcast later, right? And one of the things that happens is that
Meu marido começou um ano.
sort of like the difference when we talk about when Falcon 9 launches Dragon, right? And we say Dragon is about 13 tons in mass, but it carries 3 tons of payload. It's like, yeah, because that's part of that total mass of those 13 tons. It is carrying on board 3 tons of payload. So same deal here. We think that both landers are about 3 tons in mass, but then each one of them has their own payloads. In the case of Blue Ghost, again, I think it's like 150 kilograms that it's carrying to the lunar surface. Bunch of the mass, of course, it's on propellant because it needs to land on the moon. But that's another quick explanation there, I guess.
There's a very neat demonstration here from like a picture from iSpace that shows their landers path to the moon. Both companies have these kind of graphs that help to understand how they get there. With the, of course, actually, Alex, they have different paths to go to the moon, right? And different timelines, even though they're launching on the same rocket.
That's true. So this, for example, now that we're showing the iSpace lander, the Hakuto R lander, so that one in particular will actually take about 4 to 5 months to get to the moon. And the whole reason for that is because they're using what's called a low energy trajectory. So what the low energy trajectory, it's a bit of a misnomer because you actually need a bit more energy, but out of the rocket. The lander actually uses less fuel to get to the moon in this kind of trajectory. By using a little bit more of the rocket performance, pushing it, this lander will go out to 1.5 million kilometers up beyond the Earth, essentially. So it's gonna go to the Lagrange point 1 between the Earth and the Sun. These things where you take the gravity of the Sun, you take the gravity of the Earth, and then you combine those, and then you have these spots around the solar system where you have sort of like neutral gravity, so to speak. It's a very absurd and very simplistic explanation, but you sort of get the idea, right? Where you combine all of those gravities, you get these points in space where the gravity sort of counteracts. What they're using is they're going out all the way to that point because as they swing back down to the Earth, they use the Earth's gravity again to swing to the moon and be able to use a lot less fuel to be able to get into into orbit around the moon. It's a very efficient way to get to the moon, but it also takes a while to get there. So it's going to take 4 to 5 months. In the case of the Blue Ghost lander from Firefly, what they're doing is they're going into a high Earth orbit, which I'm not mistaken, it's supposed to be about 300,000 kilometers of an apogee. It's sort of this egg-shaped orbit, right, with the perigee very close to the Earth, but the highest point, the apogee, is way farther out, very close to the orbit of the Moon, but not entirely there. What they're going to do is they're going to use that orbit to do a lot of checkouts of their lander, because it's also the first time that they're launching this lander, right? For Hakuto, it's their second time, but for Blue Ghost, it's their first time. So they want to be able to test that, be able to check out the systems, and also it allows them to be able to launch pretty much on different timelines than you will need to get to the Moon, because it allows them to be able to phase, to be able to time their orbit correctly. They're going to be doing a few burns to be able to get out to the Moon, and the landing is supposed to be about 45 days after the launch. So we're looking, perhaps, I think they were saying today, March 2nd for the landing of the Blue Ghost. So this is going to be a lot earlier than the Hakuto R lander, because again, that's going to take 4 to 5 months to land on the Moon. So Blue Ghost will be a bit earlier than that. Funny enough, there's also going to be another lander on the way to the Moon while Blue Ghost attempts its landing on the Moon, because for the case of, you know, there's multiple landers in development, right? There's another lander that's going to land, that's going to launch next month, the Intuitive Machines 2 lander, the IM2 lander, which is going to be trying, you know, remember last year when there was this lander that, you know, tumbled when it landed on the Moon? That
We have one team locally here in Florida, and actually about an hour ago, they provided the go to SpaceX, saying that Firefly Blue Ghost Mission 1 is ready for launch. And we have our primary team in Cedar Park, Texas, in the Mission Operations Control Center, and they're really standing by. The lander is powered off at the top of the Falcon 9 rocket, and we're just in anticipation of launch.
Now let's get a closer look at the moon-bound lander. Here's Ray with an overview of Blue Ghost.
Firefly's Blue Ghost lunar lander was designed for stability. It's about 6.5 feet tall and 11.5 feet wide, so it has a low center of gravity and a wide footprint. Blue Ghost has a robust communication system with 1 X-band antenna and 3 S-band antennas that enable HD video transmission from the lander to Firefly's Mission Operations Center in Texas. The lander has 3 solar panels to help power Blue Ghost and our 10 NASA payloads during transit and on the lunar surface. For propulsion, Blue Ghost has 8 RCS thrusters, or reaction control thrusters, that Firefly designed and built in-house. These thrusters help maintain the lander's orientation during maneuvers and independently perform the final descent by pulsing for a soft landing. We have 12 attitude control system thrusters that help point the spacecraft in the right direction. These are actually the same ACS thrusters we use on our Alpha rocket and Electra orbiting vehicles. Blue Ghost has 1 main engine that provides high thrust for our lunar orbit insertion and braking burn prior to landing. The lander has 4 propellant tanks that carry our hypergolic fuel and oxidizer. We have 2 pressurant tanks that carry our helium. Blue Ghost is equipped with 49 struts that connect our upper and lower panels to provide a rigid structure. These struts were built in-house using the same lightweight carbon composites we use on Firefly's launch vehicles. Blue Ghost has 4 carbon composite legs and foot pads that utilize crushed core honeycomb to absorb shock and stabilize the lander as it touches down on the lunar surface. Our foot pads have contact sensors on the bottom that signal engine shutdown upon landing. We have vision navigation software that supports landing by identifying potential hazards on the Moon, such as rocks and craters, before determining the safest landing site.
Firefly's Blue Ghost Mission 1, Ghost Riders in the Sky, is delivering science and technology to the Moon through NASA's Commercial Lunar Payload Services initiative. This allows NASA to buy lunar delivery services from American companies for our payloads. In turn, those payloads will help advance science exploration and the commercial development of the Moon. The Ghost Riders mission includes approximately 60 days of payload operations, most of which will be spent transiting to the Moon. And then those 10 NASA payloads, they'll have about 2 weeks on the surface of the Moon to perform their tests, experiments, and other activities. Let's turn our attention now to the rocket that's going to help Blue Ghost get to its lunar destination. Joining us live is Jesse Anderson at SpaceX in Hawthorne, California. Jesse.
Thanks, Daryl. Last year, SpaceX was honored to launch the IM-1 mission, the first commercial lunar lander to touch down on the moon. We are excited to partner with Firefly for another NASA delivery to the moon as part of the agency's Commercial Lunar Payload Services initiative. This is a special mission for SpaceX today because we are launching not only one, but 2 lunar landers. And we'll share a little bit more about the secondary payload in a bit. And coming soon, SpaceX will launch NASA's IM-2 Nova-C lunar lander mission, also part of the Commercial Lunar Payload Services initiative. Also on the manifest this year are NASA's Punch and Spear X missions, as well as the return of Crew 9 and the launch of Crew 10, just to name a few. Now, it's going to be an exciting year for NASA missions.
The launch out sequence has started.
Firefly's Blue Ghost Mission 1 marks our 8th launch of the year after a record-breaking 2024 where we launched 134 Falcon missions. Also last year, our Dragon spacecraft delivered several missions to and from the International Space Station, including 2 cargo missions, CRS-31 and CRS-30, and 3 human spaceflight missions, Crew 8, Axiom 3, and Crew 9, which is currently still docked at the station. Now, coming back to today's mission, we are now at T-minus 34 minutes from liftoff. And while the countdown continues, let's take a moment to meet the vehicle that will be taking these payloads to space today. Falcon 9 is a reusable 2-stage rocket and the first orbital-class rocket capable of reflight. Since first taking flight in 2010, Falcon 9 has launched more than 400 times, including nearly 350 reflights, proving reusability is essential to sustain more advanced and deeper space exploration. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of access to space. And speaking of reusability, this is the 5th flight for the first stage booster supporting today's mission, which previously flew NASA's Crew 9 to the space station, RRT-1, and 2 Starlink missions. And after it completes its mission today, we will once again look to land and reuse the booster on a future flight. Now, this time the booster will return and land on our drone ship. Just read the instructions, which is currently on standby in the Atlantic Ocean. The first stage, which is the tallest portion of the vehicle, provides 1.7 million pounds of thrust thanks to its 9 Merlin M1D engines. Named after the Millennium Falcon from Star Wars, the 9 in Falcon 9 actually refers to those 9 engines. The second stage is powered by a slightly modified engine called the Merlin Vacuum or NVAC engine. Now, this engine has a larger nozzle, which allows the second stage to perform more efficiently in the vacuum of space. The first stage gets us out of Earth's atmosphere and into space, while the second stage takes the payload to its targeted drop-off orbit. Now, the large barrel structure with the pointed nose cone at the very top of the vehicle is the payload fairing, and it's composed of 2 halves made up of carbon composite material that come together to protect the payloads until we're in the vacuum of space. We'll be attempting to retrieve the fairing halves once again with our recovery ship, Bob. Both halves of the fairing flying today are flight proven, with one side flying for the 20th time and the other for the 12th time. And there you can see on your screen the Blue Ghost lunar lander there, integrated to Falcon 9's second stage in preparation for launch. And you can't see it, but there is a second payload in the photo, iSpace's lander Resilience, which we'll talk about a little bit more later on in the show. Now, Resilience is encapsulated in the payload canister, which is just under Blue Ghost. This is to protect Resilience from the spacecraft above it during launch. Now, when the rocket launches, the canister takes the launch load of the Firefly spacecraft and their payload adapter and transfers it to the rocket structure. Now, it continues to be a smooth countdown. Weather is holding steady, and we're looking good for an on-time liftoff. So while we wait, let's check back in with Daryl and Ray.
All right, Jesse, and our hearts go out to everyone at SpaceX who's been impacted by the wildfires in California, and everyone who's working this mission today and pulling it off. Despite those challenges, we greatly appreciate it. All right, joining me now is Firefly CEO Jason Kim. He's here to talk this mission and what lies ahead for the aerospace company. Jason, you've got decades of experience in the aerospace industry, but you've only been with Firefly for a little more than half a year. How's it been going for you so far, leading this company?
Well, it's funny you say that. I actually was a customer of Firefly on the Space Force's Victus Nox mission back in. We launched a 24-hour notice mission back in September of 2023. So I got to know the team members. I was just really impressed with everybody at Firefly. It's a very bold team. It's a can-do spirit, and very exceptional in terms of engineering, rocket engines, carbon composites. I can just go down the list.
Right. Very impressive in terms of what the company can do, as you say, but Firefly does have the opportunity here to be the first company to soft land on the moon. What gives you, as CEO, confidence that your team's ready to pull that off?
Well, I've been through many different high-stakes critical mission operations campaign. It starts with a great launch, so we've got a really reliable, great partner for the launch. But once we separate it, it's all on Firefly, and we've got a great design. It's a great design with margins built in, good parts selection from a great supply chain, and we're very vertically integrated as well. And then I would say that each subsystem is qualified with many hours. The whole lunar lander is qualified. We did the environmental test at JPL, so our hearts and minds go out to everyone in Los Angeles and at JPL. And then, it's down to the people. Our people, our Fireflies, they've rehearsed for many, many hours. They've done dozens of simulations. Our team is back in Cedar Park. They're ready to go. They've been training really hard under Ray's leadership, and they have trust and confidence in each other. And at the end of the day, it's the people that are going to make this successful.
And there's an added component to this that I'm wondering if you can share with us. You shared this in a press conference recently, that you talked to the two companies that preceded you in attempts in going to the moon, Astrobotic and Intuitive Machines. You were encouraged to call those CEOs and find out what lessons they had to share. Can you share what they said?
Well, first of all, it's something that I wanted to do. That's just my style. I love competition, but in the big scheme of things, we want the CLPS program to be as successful as it can be. I talked to Pam Melroy, who I respect and I've known for many years, and she gave me that advice. You ought to talk to each of the CEOs and find out more. And so that's what I did, and they were very cordial. They took my call. We had great conversations. The number one thing that they would both recommend and advise me on is for our team to be transparent. Open and transparency is really key to get all the support that you can get from the whole world, the nation, NASA, everybody. Secondly, we've looked at all the missions that came before us. It's really hard to do space missions. Going to the moon is even harder.
It is.
And so it's challenging to do that soft landing, as you know. But our team has looked at systematic things that have happened in the past, looked at, the hardware and software. And our design it goes back to the design is a great design with margins. Did tons of testing, both environmental testing as well as air testing, and the actual crumple zones that we have with our pads. That's gone through different angles of testing and geometries.
A thorough testing campaign.
Very thorough.
And probably don't need that shamrock on your lapel after all, because the team's been doing so well. Hey, Jason Kim, appreciate you being here. Thanks for coming on.
Thank you.
Good luck to you today.
Yeah, go Blue Ghost.
All right. Firefly started with about half a dozen employees. Now the company has over 700. Ray has been there since day one, and she's going to show us how the Firefly team got through the last leg of Blue Ghost's journey, the rigorous testing campaign. Let's take a look.
Over the past 3 years, our Ghost Riders have navigated through major key milestones. The initial phase centered on design qualification. Our engineering team conducted comprehensive analysis of the lander's structural and functional requirements. We then shifted to subsystem testing. We validated carbon composite structures on the test stands, verified the landing navigation system on a simulated lunar surface at our rocket ranch, and evaluated landing performance through nearly 100 drop tests. For our NASA payloads, we performed detailed fit checks to confirm compatibility with the lander's design specifications. We began the lander assembly process by integrating our fluid lines, COPV tanks, and avionics with our structural assembly. The NASA payload teams then traveled to Texas to integrate their components onto the lander. Following this, propulsion system integration involved mounting the main engine and 8 Spectre thrusters to the lander. Next, we wrapped the lander with MLI, or multi-layer insulation, to protect its systems from extreme space temperatures. The fully integrated lander was transported to NASA's Jet Propulsion Laboratory for comprehensive environmental testing, subjecting the spacecraft to simulated space and lunar surface conditions. Simultaneously, we began mission operations training, conducting over a dozen mission simulations from our Mission Operations Center in Cedar Park, Texas. These exercises allowed our team to practice operational scenarios and refine mission protocols for game day. Upon returning from JPL, we performed final subsystem checkouts and inspections of the lander, verifying all lander systems and configurations were ready for flight. Finally, we shipped the lander to the Cape, preparing for its ultimate journey that begins today.
Once the Blue Ghost lander gets to the moon, there are 10 instruments on board that will play a key role in navigating and studying the lunar surface. Joining us now is Mike Selby, who is the mission manager for 2 of the payloads, LMS and Lister. So let's start it off with LMS. That stands for Lunar Instrument, well, actually Lister. Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. It's a doozy.
It is.
It measures the flow of heat originating from the interior of the moon. So, Mike, why is that important?
So it's important to learn about how the moon has evolved over time. So Lister is a pneumatic drill that is going to use compressed air to drill down in half-meter increments, hopefully to a depth of 3 meters in total. But in those half-meter increments, it's going to deploy a probe that will make thermal conductivity
Stage 1 landing like deployed
to help determine how the moon is formed.
And it's going to drill just like we see in this video right here.
Absolutely,
it's
yes.
Kick up a lot of regolith.
Kick up a lot of
Stage 1
regolith.
landing confirmed.
Absolutely.
All right,
And
as
you
it goes down and
saw
goes in, it's
and
going to
heard,
get those
we had
temperatures.
successful
Let me ask
first
Ray, how do you integrate a drill underneath your lander?
Yeah, so the drill was really fun, definitely a team favorite. It's one of the payload it's mounted on the bottom deck of our lander, and it's facing the lunar surface. So some of the other payloads are looking up, out. Lister is looking down so that it can do exactly what Mike just said, drill into the lunar surface.
All right, let's go to LMS now. That is the Lunar Magnetotelluric Sounder, or LMS. It measures the natural variations in the electric and magnetic fields from the solar wind and Earth's magnetosphere to determine the electrical conductivity of the moon's interior. All right, well, so we're looking at it now.
Yes. And so what you can see there, the remote electrodes that are basically an electrode with wire around it, and they're going to be ejected, 4 of those from the lander on 90-degree increments. And so opposing pairs will operate kind of like a voltmeter, making those electrical measurements of the moon.
Right. And there's 4 of them, it looks like. They look like they're about the size of a pickleball.
That would be correct, yes.
Or softball.
Yeah, and they'll be deployed hopefully about 60 feet out from the lander.
That's amazing. So, Ray, if these things got to kick out from the lander, how did you coordinate where they were going to go?
Yeah, so we talk about these 10 payloads. There's 28 different components, and this is a great example of that. So these probes are mounted on the edge, and as he mentioned, they'll shoot off the side of the lander, and then there's also a mast on the top deck that will shoot up. So there's going to be communication from the probes on the lunar surface up to that mast. So it's very interesting.
A complex arrangement, but we're going to get some exciting data from it.
Absolutely.
Mike Selby, thank you so much for coming and joining us today.
Thank you.
And good luck. All right, for explaining those LASA payloads, we appreciate that. We're going to go back now and check in with the rocket with Jesse Anderson live at SpaceX in Hawthorne, California. Jesse.
Thanks, Daryl. And that was so cool to see how interesting that NASA payload is going to be. Very excited to see, what data we can gather from that. SpaceX is part of the Artemis campaign, which includes CLPS that will further lunar exploration with NASA. At our headquarters in Starbase, Texas, we're continuing to rapidly build and test Starship, which will enable us to send large amounts of cargo and crew to the moon, Mars, and beyond. 2024 was a huge year for Starship, and 2025 is going to be even bigger. We've completed 6 test flights so far, and 4 of which were last year. And we're looking to dramatically increase the number of launches of Starship this year with tons of exciting firsts coming, like in-space propellant transfer and our first attempt to catch the upper stage of Starship. Starship had some absolutely mind-blowing moments in 2024, most notably the first booster catch, which saw the Super Heavy booster return to the launch tower to be caught out of mid-air on the chopsticks, a major milestone to the path of full reusability. These flight tests are critical for iterating towards a fully operational vehicle because the more we fly, the faster we learn. Development and manufacturing of Starship takes place at Starbase, one of the world's first commercial spaceports designed for orbital missions. Many new buildings and facilities, including the new launch tower and the 1 million square foot Star Factory designed with the goal of producing hundreds of ships a year, were built at Starbase in 2024.
Complete.
There's tons of work still to be done as Starbase continues to grow and transform into the gateway to Mars. And in addition to all of that, construction is underway at Cape Canaveral's Launch Complex 39A, where an additional Starship launch tower will be coming online. There's so much to look forward to in this era of space exploration, and we couldn't be more proud of our work with NASA to help humanity go beyond low Earth orbit again. But back to today's mission, let's learn more about payload, iSpace's Resilience lander. For its second mission to the moon, iSpace aims to achieve a soft landing on the lunar surface, deploy its proprietary micro rover named Tenacious, explore the moon's surface, and collect samples. Now, during the journey to the moon, the lander will conduct a lunar flyby, the first by a commercial lunar lander. And after its 4 to 5 month journey, Resilience will set down in the Mare Crisium, where it will explore the lunar surface. Resilience is part of the Hakuto R lunar exploration program, which represents iSpace's first 2 lunar missions. Resilience is carrying 6 payloads, including Tenacious, the first lunar rover completely designed, manufactured, and assembled in Europe. And if successfully deployed, it could be the first commercial rover to explore the surface of the moon. For a bit more on Resilience, we have a few words from iSpace.
After more than 100 days in space, Hakuto Mission 1 had ended. The voices of support that we received from all over the world gave us the confidence to not quit the lunar quest. And what we learned throughout our first mission was invaluable. Every technical issue solved, every struggle overcome, every bit of information analyzed, all preparing us for our next move. Today, we're going back to the moon. Improving and optimizing our processes, we have confidence in our ability to carry out this second mission successfully. We work with governments, agencies, and numerous commercial customers, both with and without experience in space, to bring new technologies, businesses, and perspectives to the moon by providing transportation and data services. iSpace is different because it's our vision to expand human activity beyond Earth and to create the future cislunar economy. Today, we prove our resilience as we launch Hakuto Mission 2, Venture Moon. On this mission, we go beyond lunar landing and aim to explore the moon's surface with our Tenacious rover. We are iSpace, and with a global team, we're building the cislunar economy. On today's mission, we carry 6 payloads ready to bring technology, science, art, and culture to the moon.
We are committed to secure humanity's future on Earth and beyond.
We offer an entry point into the cislunar market for everyone who is ready to join us on this amazing venture.
For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. Preparations for Artemis 2 are underway, and we have more on that in the Moon Minute.
Hi, I'm NASA astronaut Victor Glover, pilot of the Artemis II moon mission, and I'm here at the Vehicle Assembly Building at NASA's Kennedy Space Center in Florida, where behind me, booster stacking is beginning for the Artemis II rocket. Mission progress
yes
got a
and
big
no.
boost recently when
They're still
technicians
obviously
with the
doing their
Spaceport's
preparations and
Exploration
keeping their
Ground
rocket
Systems
out at the
inside
pad, which is totally
VAB
fine.
Began
The
stacking the first components of the Space Launch System rocket, the solid rocket boosters. 10 segments arrived by train to Kennedy in September of 2023, followed by extensive testing and inspections to prepare for stacking. Technicians inside the VAB are using the massive overhead cranes to stack the segments one by one onto the mobile launcher, which will be used to process, assemble, and launch the SLS rocket. Once all 10 segments are stacked on the mobile launcher, 5 on each side, the boosters will then help support the remaining rocket segments during final assembly, including the core stage and the Orion spacecraft that will take Reed, Christina, Jeremy, and me around the moon and back. The 177-foot tall twin solid rocket boosters will provide 7 million pounds of thrust during liftoff of Artemis II. That's a look at your Artemis Moon Minute.
Time now to tell you about another one of NASA's 10 lunar payloads on this mission. Next up is the the EDS, Electrodynamic Dust Shield, which uses an electric field to move harmful lunar dust off the surfaces in need of protection. And here to show us how this payload works is the principal investigator, Dr. Charles Bueller. Are you ready for some show and tell, folks? This one's going to be fun.
That's right, I got some props here to share.
All right, first of all, talk about EDS. What is it and why do we need it?
The EDS is a system developed here at KSC for the last 20, 25 years or so.
Wow.
To lift and remove dust from surfaces without any moving parts, gases, or fluids. And we incorporated our EDS technology into various substrates to do just that.
And that's important because this regolith on the moon, it's abrasive, right?
It's very abrasive and it is potentially toxic, yes.
So we don't want that on our equipment or spacesuits or anything that's moving. Okay, so how does, you've got this setup here.
Sure.
And to your left, the thing that you're holding there, that's kind of what is encasing your payload, right?
This is actually the spare parts of our payload.
Okay, all right. So explain how that works when it gets on the moon.
So when we land on the moon, a few hours after landing, we deploy a fifth leg, or an SAA, Surface Access Arm, which will deploy 2 instruments, us and Planivac, and it will jettison us separately after that, a few hours later, and we will softly land on the moon like this.
And how are you going to make sure that you get regolith inside there? Because you need that dirt in there. You want it to get dirty.
We absolutely do. So we're trying to focus on 2 EDSs, self-cleaning surface, a glass and a thermal radiator. And what's going to happen is when we land, we have 6 other EDSs that their whole job is to lift dust from the surface and direct it and deflect it onto our EDSs.
Hold that up for a second, Dr. Bueller, because you can see through those little bands, right? What are those? It looks like that the dirt can pass through them.
Those are just electrodes. The same thing in our transparent EDSs.
They can kick up the regolith onto it? Okay.
Okay,
and so now let's show us how this technology works. Once you get it dirty,
once you get it dirty with the reduster, you can show here. So if you have a glass system, a camera lens, or something,
we got a camera.
You can get
overhead.
it really dirty on the moon.
Oh yeah, okay.
And that's bad news.
Yeah.
So you don't want that. So you want to turn on your EDS, and then voila, dust will
Look
come
at that, just
all
right off
clean.
the surface.
Yeah.
And that is electrical current that's created.
That is an AC square wave signal.
Okay.
Low current.
Now, can we give it a tougher test? Can you really get this? I mean, we can get my 1.5-year-old to come in here and throw dirt. He's very good at throwing dirt. If you need help.
Well, we'll keep adding dust. Why not?
Yeah. Hey, it's live TV. What could go wrong? Yeah.
Cover the whole thing. How about that?
Now you're talking.
And what I can also do once we de-energize that might take a few more minutes. It doesn't take too much longer.
So if that's harmful regolith, literally nothing moving, no moving parts, no gases, and it's just coming off the surface, and it still continues to work it right off.
Yep.
That's fantastic.
And what's nice is if it's on, we can't get dust to stay on it. That's also very useful.
That's fantastic because these little dust particles, as I understand on the moon, as you were just talking, are like little shards of glass. So you don't want that stuff to stick. What do you expect to happen on the moon when you do this?
Now, on the moon, we have to polarize the dust, so that takes a little bit longer. So we apply a DC field for a few seconds, a few minutes. And that's based on the resistivity of the dust.
Okay, and Ray, it's been pretty fun to watch that, happen, and you had to make sure that this had good access to the regolith. How'd you do that?
Yeah, so as he mentioned, we designed this surface access arm, and so when we land on the lunar surface, that arm will deploy down, and then there's a hinge that we very specifically designed to get EDS to flatly land on the surface and get that dust up in it the way it needs to perform its science objectives. So.
And you can kick up a little more regolith if he needs it?
Yeah, well, there's other activities going on the lander that I think will really help get dust on there. The Lister drill will be running. There might even be some dust from landing, that impact kick up a little. So we'll try to get a lot of dust on your payload to help you out.
I appreciate that.
All right, very good.
Want to be dirty.
I want one of these for my entire house. And just punch it and all the dust goes away. Then you really have something. We are looking forward to this experiment. Thank you, Dr. Charles Bueller, for being here. Thank you for the demonstration. And Ray, appreciate your insight on how you integrated into the payload. That's great.
Thank you very much.
All right, time now to tell you about another one of NASA's 10 lunar payloads. We're going to have so much more of these lunar payloads coming up in the show. We're going to get to that in just a little bit. You may have heard us mention CLPS, which is the Commercial Lunar Payload Services program at the beginning of the show. Let's dive a little deeper now into this relatively new NASA initiative.
Our moon. It seems so close in the night sky.
Muita
but
historinha, né?
Is really hard. But what if there was a way to change that? Only a few nations have successfully landed.
Actually, if they have any countdown where they talk about this and they meet together.
This time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human
Muita
exploration.
historinha, muita
To
animação.
make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery services to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for
Daqui a
exploration,
pouquinho.
radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
And we're getting close to liftoff, just T-minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket. Ray, the journey to this moment began for you and your team more than 3 years ago.
Yeah, it's been quite a journey getting here. This contract was awarded in early 2021, and so all of this work over the last few years is leading to this moment.
And you've got a pretty big team. Talk a little bit about that.
Absolutely. We have a team of dedicated engineers, operators, technicians, and support staff that have been working tirelessly to make this mission a success. I'm incredibly proud of what our team has accomplished and what we'll continue to accomplish once Blue Ghost begins its road trip to the moon.
And what's your sense of how the team is feeling right now? You've done a ton of preparation. You've been there from the start with these folks.
E aí, galera, tem alguém comigo aí?
Yeah, the team right now, I think, is just filled with anticipation, excitement. I was messaging some of them earlier, and I think today it really started to set in. When you see that Falcon 9 go vertical on the pad. So just excited to finally start our journey.
And we're looking live at the Mission Operations Center in Austin, Texas. Firefly Aerospace. You can see the folks sitting there. This is the mission team. This is the team that's going to be there all the way to landing and
Engine
beyond.
chill has started.
Absolutely. So you can see all of them kind of sitting there. They're getting prepped. They're getting their consoles set up. They'll probably start getting some initial data from that first ground station, but otherwise, with the lander powered off, they're really just waiting for deployment and power on.
Ray, I'm wondering, Firefly, as a company, you've launched before, but this is the first time that you're launching to the moon. Is it different?
I think it's a little bit different. I'm sure the Alpha team, the first time they launch, they feel very similar to how I feel right now. But really for launch, it's a few hours and then your mission's over. For us, this is really just when our mission
Stage
begins.
1, fuel
and it
load
leads
complete.
into these 60 days of operations in orbit and on the surface. So it's kind of a surreal feeling. It's hard to explain.
And you get to look up at the moon at night and say, we're going there.
Yep. So I think all of us kind of started looking at the moon a little differently. You know, leading up, the engineers would text us, 3 full moons till we launch, 2 full moons till we launch. And so you look up at night and you get filled with excitement.
Well, we are excited as well. We're going to go out and watch that launch. In the meantime, there's the moon. There's where you're headed. Let's send it back to SpaceX in California as they walk us through the final moments of the countdown.
Thanks, Daryl. At T-minus 5 minutes and 40 seconds to liftoff, all systems are currently go for non-time liftoff at Launch Complex 39A at Kennedy Space Center. And the moon was looking great, but we were waiting for a call out for the strong back retraction coming up here shortly. What's going to happen is the clamp arms around the top of the second stage, which is just below the fairing, will begin to open up. Once those clamp arms open up, then we'll begin to move the strong back away, slightly away from the vehicle. And that process will take about 20 seconds. Vehicle, the TE or transporter erector will be just about a couple degrees away from the vehicle. And then at T0, we'll move it about 45 degrees above the pad deck.
For strong back retract.
And that will make the way for liftoff for Falcon 9. And we did hear that call out that we are preparing for strong back retraction. That should be coming up here in about 20 seconds. The strong back is that vertical structure just behind the vehicle that you see there on your screen.
Strong back lower has started.
And there's that call out that the strong back retraction has begun. Now, again, what you're going to see is those clamp arms just below the fairing are going to begin to open up. And once they're fully open, that'll make way for the transporter erector to move away from the vehicle. Now the TE, or the transporter erector, is carrying the propellant, electrical, and gas lines to stage 2 as well as the payload. And there you can see on your screen that those clamp arms are now opening up. This is a good view here because you'll be able to see that TE start to move away from the vehicle. It's pretty slow, but you should be able to see it here in a few seconds. And there you can see that TE starting to move away from the vehicle. And once Falcon 9 commands for liftoff, hydraulic cylinders pull the strong back even further away, again to that position about 45 degrees above the pad deck. Now we are coming up on liquid oxygen loading completion at the T-minus 3 minute mark. For some reason,
Stage 1 launch load complete.
There's that call out we were waiting for. Stage one liquid oxygen loading is now complete. If for some reason we do not launch today, we do have a backup opportunity tomorrow, January 15th at 10:09 p.m. Eastern Time. Currently, weather is green and the range is ready to support a T0 of 10:09 p.m. Eastern Time. And the landers continue to be healthy, and the Falcon 9 team is tracking no issues on the vehicle. Next coming up will be at T-minus 2 minutes.
2 minutinhos, hein, rapaziada.
Stage 2 LOX load complete.
Right on time. That is stage 2 LOX load complete. That means propellant loading is now fully complete on Falcon 9. The vehicle is now fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. And just a correction, it is 1:11 a.m. Eastern Time for liftoff tonight.
Gas launch closeouts has started.
Now that the propellant loading is complete, we should begin to see venting coming from the transporter
Qual
erector.
foguete é o Falcon 9?
That is just clearing out those propellant lines from the TE in preparation for liftoff.
Vambora, rapaziada, é agora.
Falcon 9 is in startup.
Good call out. This means that the Falcon vehicle's internal flight computers have taken over the launch countdown. We're now just waiting for the final go from the launch director.
LD, go for launch.
And great news, we are go for launch, so let's watch as Falcon 9 takes our 2 lunar payloads out to space.
T-minus 30 seconds.
É agora, hein, rapaziada.
T-minus 15.
Esse foguete aí vai levar...
10, 9,
Ó,
8,
contagem regressiva.
7,
Ele vai levar 2
6,
bases para a Lua, tá?
5, 4, 3,
Vambora, foi.
2, 1. Ignition. And liftoff. Go Firefly, go iSpace, go Falcon. Vehicles pitching downrange.
Foi embora, hein, rapaziada.
T plus 30 seconds into launch, Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center. Now the vehicle is going vertically, but it will begin to move horizontally. We're going to gimbal
Power and telemetry are nominal.
We're going to gimbal those engines. We're still going up, but now
Engine air pressure is
É
nominal.
ao vivo, rapaziada. É
Vehicle
ao
is
vivo, tá?
supersonic.
we'll be moving horizontally, and that helps the vehicle get into orbit and avoid being pulled back down to Earth. And we are coming up on max Q. This is the largest structural load that the vehicle will see during ascent.
Max Q.
There's that call out. We've passed through max Q. And we do have a few events coming up in quick succession. That'll be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we will shut down all 9 of those M1D engines that you see there burning bright on your screen. That prepares the vehicle for stage separation. That's when the first and second stages separate from each other, and the first stage will begin to make its way back down to Earth, while the second stage carries the payloads and continues with its journey with SES-1, or second stage engine start 1. And that's where we will ignite the NVAC engine on the second stage, and shortly afterwards we will have SECO, where the vehicle will coast. So we are coming up on those 3 events that I just mentioned: MECO, stage separation, and SES-1 in just about 20 seconds from now.
Travando assim.
Some really cool tracking views here of Falcon 9 and those 9 Merlin. And great views. We watched as we shut down those 9 Merlin M1D engines, stage separation, and now you can see there on your screen that MVAC engine has ignited, again carrying the 2 lunar landers aboard Falcon 9's second stage. And there on your left-hand screen, you can see that the first stage is deploying its grid fins. Those hypersonic grid fins will help guide the vehicle back down to Earth. And in about 15 seconds or so, we will also have fairing deploy. We have the fairing protecting the payloads through ascent. But once we're in the vacuum of space, we no longer need that protection, so we will jettison those fairing halves.
Fairing separation confirmed.
and a really cool view of the payloads encapsulated in those fairing halves, the fairing halves deploying. We will once again attempt to retrieve these fairing halves once they make their way back down to Earth. And in a few minutes, we will also have a couple more burns for our first stage to prepare it for landing on our drone ship. Just read the instructions. We are T plus 4 minutes and 10 seconds into today's mission. We're currently in the first of 3 planned MVAC burns. Around T plus 6 minutes, you should see on your screen the first stage's entry burn. Now that entry burn is where we ignite 3 of the Merlin M1D engines, and that's going to be the E9 engine plus the E1 and E5 engines. Now that helps slow the vehicle down as it's re-entering back into the Earth's atmosphere. Now the reason why we slow down the vehicle is to reduce the re-entry forces, which helps us recover and reuse the first stage booster. So far everything is looking nominal. Stage 2 still carrying our lunar payload on a nominal trajectory. Again, the first stage vehicle is making its way back down to Earth. We're about 45 seconds away from the entry burn beginning. And just as a reminder, the first stage booster that is supporting today's mission will perform this entry burn for the 5th time. Falcon 9 is the world's first orbital class rocket, reusable rocket, and this is important because reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. So we do have that entry burn coming up just about 10 seconds. Again, that will be 3 engines reigniting for just about 20 seconds or so.
Stage 1 entry burn startup.
Stage 1 FTS is saved.
There's that call out, and on your left hand screen you can see that those engines have ignited. And helping to slow down the Falcon 9 booster as it's making its way back down to Earth.
Stage 1 entry burn shutdown.
And there we heard the call out as well. As you can see that the engines have shut down. That concludes the entry burn for the Falcon booster. Coming up next in about 1 minute will be SECO. That is second stage engine cutoff. And that'll basically be where we shut down that MVAC engine and allow the second stage to coast with the payloads.
Stage 2 is internal guidance.
As the vehicle is making its way towards its targeted drop-off orbit for each of the lunar landers. And just shortly after we have SECO, we'll also have the landing burn startup on the booster. So we will have a couple events happening back to back.
Stage 2 FTS is saved.
Stage 1 transonic.
For the landing burn, we reignite the center E9 engine. And again, that slows the vehicle down just in time to touch down for landing. We have SECO 1 coming up, as well as the landing burn in just a few seconds.
SECO.
Stage 1 landing burn.
Nominal orbit insertion.
Full view of first stage, touching down for landing.
Landing leg deploy. Stage 1 landing confirmed.
And there you can see on your screen the Falcon has landed on Just Read the Instructions. That marks SpaceX's 398th recovery of an orbital class rocket, and that includes first stage landings for Falcon 9 and Falcon Heavy. We're just waiting for confirmation of good orbit. And we have had SECO, that is second engine cutoff 1 for that NVAC engine. And we are just waiting to confirm good orbital insertion.
Quem curtiu aí o lançamento?
And we have confirmed good orbital insertion. Now the mission isn't over just yet. Coming up next, we have the second burn of our MVAC engine, or SES-2, on board the second stage around T plus 58 minutes. So, and then that'll be followed by payload deploy. So until then, we're going to send it back over to you, Daryl, at KSC.
All right, thank you very much. If you're just joining us, we are just into the mission here. T plus 10 minutes and 30 seconds into the flight of the Falcon 9 with the Blue Ghost riding aboard. And it was, as you can just hear, a nominal orbital insertion. Great news. We just witnessed it live right here from the Space Coast at Kennedy Space Center. And on board are 10 NASA payloads headed towards our moon. We have Ray Allensworth, who is here, the spacecraft program director. You and I were just out there watching it live outdoors, just 3 miles away. How did that feel?
I can't stop giggling. No, I mean, it's one thing to watch a rocket go. It's another thing to know that your payload's on the top of it. So it was incredible.
É isso aí, galera. Eu vou fechar aqui pra vocês. Tamo junto. Valeu quem acompanhou aí pelo YouTube. Até a próxima. E é isso.